Welcome to the iLearn Virtual Campus. Please sign up for a free iLearn membership on our website, check out our 7th annual conference coming next spring 2021, and let us know if you're interested in hosting events or leasing space on our campus by emailing campus@immersivelrn.org.
Now the blue lines are gone. Okay, now everybody hears us, huh?
Yes.
Okay. So Daniel, du hörst uns auch, oder?
Ich kann euch hören.
Leider kann man nicht flüstern, glaube ich, oder?
Aber wird es nicht so ein bisschen gedämpft, je nachdem, wie weit man weg ist?
Ja, man weiß es halt nicht. Das hängt mit der Einstellung im Raum zusammen, glaube ich.
Alles
Also ich
klar.
sitze ganz hinten und ich höre euch richtig
Solange wir
gut.
Deutsch reden, sind wir zumindest ein Drittel geheim.
Genau. Du hast ja auch ein Paper, habe ich gesehen, in der Session, die ich am Freitag.
Genau, ja. Ja, über so
No nosso
Alignment
Facebook,
Techniques.
hein?
Muss ich mir noch ein paar Fragen auf.
Valeu, obrigado, Chirino.
Ich muss es noch durchlesen, ehrlich.
Ach, bist du Session Share? Doch?
Mhm. Ja.
Oh, okay. Oh, so it's starting.
Wir können uns ja später nochmal unterhalten.
Do seu lado, professor.
First, we will show the fast forward of the poster sessions that will happen on the ASMR Expo Hall. So please play the video. Okay.
Remote collaboration in augmented reality has been devoted to the creation of the enabling technology. However, there is a lack of guidelines to guide the characterization of the collaborative process. In addition, evaluation is particularly challenging in this multifaceted context, involving many aspects that may influence the way collaboration occurs. As such, we propose a conceptual model for multi-user data collection and analysis and scenarios of remote collaboration mediated by augmented reality.
Hello, we present a real-time gate reconstruction for VR using
Cuidado que muta all, muta João.
our AI model predicts gate phases to trigger equivalent synthetic animations without simulator signals.
We present a simple yet effective user-aided global registration method for outdoor AR. And for this purpose, we use geospatial models like 3D terrain or city models that virtually represent the user's environment, and via two simple touch gestures, the user can then manually align these models to the real world view to precisely correct the global camera pose while achieving a high degree of immersion for outdoor AR scenarios.
This research aims to determine the intention of using the R app by students. An interactive R app on electrical circuits was developed. The app allows the manipulation of circuit elements, computes the voltage and amperage values. The results show that the app is well evaluated on the intention of use by students. It also determined that the students who carried out the online survey presented a higher behavioral intention to use than those who participated in the guided laboratory.
Our study examined factors of social influence from AR virtual humans. Previously, we found that there is a social influence from AR virtual humans, but not why. Based on the social influence theory, we examined anthropomorphic and behavioral realism. The factors were tested through 3 experimental conditions. In our manuscript, we report results based on behavioral measurements. We hope you to check out our work.
We present a mobile application, MRCAN, for the visually impaired. MRCAN is VR plus AR. The app supports various audio and vibro-tactile feedback. For example, when they touch the wall with a virtual can, they will hear. When they touch a metal object, they will hear. MRCAN also supports a third view to monitor their movement. To use MRCAN, simply attach the phone to a selfie stick and move the selfie stick like a white can. For more information, please come to us. Thank you.
With our poster, AR Minigames for Supermarkets, we present a Unity 3D application including 3 AR minigames. The image marker-based minigames contain 2 different types, generic or product-specific, and several interaction techniques at specific locations and pallets during the shopping. Due to the supermarket environment and the time constraints during shopping, we aim for relatively simple but interesting games. A coupon collection scene completes the fun AR shopping experience.
Does augmented reality visualization improve puzzle training? The result of our research shows, from user study, how visual perception in augmented reality improves in terms of posture and safety the gait exercise to overcome an obstacle. This study was carried out with the staff of Takanohara Central Hospital in Japan. Thank you for your attention.
In this work, we describe the design and development of a prototypical VR learning application, which is used to demonstrate the concept of utilizing immersive technologies within a prison context. This led to the commercial development of an immersive learning system, which we were able to use for an exploratory study at a local correctional facility. We were able to attain various insights into the implementation and use of immersive technologies, not only in highly regulated and potentially volatile prison environments, but more general learning spaces.
In our poster, we focus on the Superhuman Sports multiplayer game, which is centered around a throwable and catchable drone, which is also augmented through the use of head-mounted displays. We built a special cage that has 3 rings of LEDs strapped around it, which can be used for LED pattern recognition in a self-made OpenCV algorithm. We then lastly focus on our vision to build a full game implementation in Unity, handling game logic and networking, etc.
Through the last decade, the creation of extended reality solutions has increased due to the advent of new headsets, development kits, smartphones, and engines. Our toolkit is focused on the challenges innate to XR, consisting in a design process, a continuum of techniques and guidelines, and a set of games that guide users through the design process. With this work, we intend to help beginners and experienced teams in the creation of applications and interactions in XR.
This presentation is about using Space Index to enable a walkable ER experience. Space Index refers to analyzing the spatial properties of the space or building. Scavenger ER, a site-specific approach, implements Space Index rules for object placement, question mark, and coins. 3D question marks are placed at different locations inside the building with high openness and visibility. Coins are placed at locations with low visibility, openness, and connectivity. Adventure AR, a site-agnostic approach, implements Space Index rules for object placement.
we present the locomotive and cognitive trade-offs for target-based travel techniques. Specifically, we evaluated the travel performance and cognitive loads of a point and instant teleport technique, a point and walk motion technique, and an automatic walk motion technique. We used a dual task methodology that employed a Fitts law-based travel task and a two-back cognitive task. Our results indicate that teleport afforded the best travel performance and automatic afforded the best cognitive load.
The purpose of this study was to evaluate the travel performance and cognitive load of 3 steering techniques. By using dual task method including 2 back verbal tasks while concurrently performing a Fitts law-based travel task, we found that gaze and hand-directed steering were equivalent. Gaze-directed steering induced significantly less motor sickness. Thus, developers should include gaze-directed steering as an intermediate travel option between teleport and hand-directed steering.
Ginput is a language that encodes gestures with natural language. We implemented Ginput in Unity to prototype virtual reality gestures. In this example, the cube becomes green when the point gesture is performed. Here, each gesture triggers a spell cast. Notice how these gestures are a sequence of 2 poses, which means that they are dynamic gestures. Ginput also supports gestures with buttons.
Underground environments are GPS-denied spaces, which require sophisticated indoor navigation solutions. In this study, we evaluated the performance of AR-assisted navigation in a real underground mine with good and limited illumination conditions. You can see the different scenes with the different illumination models. And also you can see the total time of completing the route. We found that AR-assisted navigation is effective for support search and rescue efforts.
Human pose estimation techniques have been playing a major role in many extended reality applications, such as activity recognition, physiotherapy, and gaming. We present HuTrain, a framework for users to fastly generate human pose estimation datasets from only a set of synchronized input videos of an environment. We also propose an automatic human-based calibration algorithm for estimating the camera pose of each video. With HuTrain, users can target specific domains of human pose according to their application needs.
Hello everyone, my name is Alban Delamar. I'm a PhD candidate at Florida International University, and I'm going to present our work on modeling emotion for training with immersive simulation, a cross-platform virtual classroom study. So we created a virtual classroom simulator that can play on a PC and on a cave, and we will combine it with students that can display facial expressions to observe their effect on the user's feeling of presence, co-presence, engagement, and believability.
Hello, my name is Natalie Huber, and in our poster we present our comparison of a pre-evaluated mapping approach with the state-of-the-art direct mapping method of facial expressions for emotion judgment in an immersive setting. We present our implemented mapping pipeline and details of our user study with 22 participants. Although we could not find any differences regarding potential uncanny valley effects, we found that participants were more confident when deciding on emotions. Overall, the pre-evaluated mapping shows potential to be more convenient in a conversational scenario.
We present Mixer, Music and Mixed Reality, an augmented reality sheet music system for HoloLens and mixed reality devices. With Mixer, performers can view, manipulate, and annotate virtual sheets of musical compositions in AR and their environment. Our system helps musicians deal with common issues in music performance and practice by allowing them to manipulate sheet music in such a way that facilitates acceptable posture and improved sound, while using either AR or smartphone interfaces to control and set the behavior of sheets rendered in their environment.
We design a tracking system and an accompanying method for commercial AR that can accurately track small and movable objects such as surgical training apparatus. It uses a set of small, close-range, and unsynchronized borescopes that are calibrated quickly with static markers in the operation area, and it uses Vive trackers to track the movable borescopes on the surgical manipulators themselves. We test the system on both the HoloLens and Magic Leap, and find reasonably good tracking of a small surgical donut through a peg transfer test, with minor discontinuities when the donut moves between camera scopes.
This work was created for the Stanford Immerse Lab to explore how different static visualization techniques influence users' ability to perform perception-based alignment in AR. For breast reconstruction surgery, surgeons must accurately identify the location of several perforator blood vessels while planning the procedure. Results from our pilot study indicate that the highest alignment error was along the user's depth dimension, and visualization techniques rendered with lower levels of opaqueness and brightness, as well as higher outline contrast, performed best.
Today's AR systems are largely task-driven and not very convenient for always-on context-aware AR. We instead design an object-centric multitasking interface. Our interface on the right situates the app menu in the environment next to the object itself. We compare this to the approach used in current HMDs. In the pilot study, our interface was faster, felt easier to use, and users preferred it overall. These results are really encouraging towards better task switching for always-on AR.
Hello, I am Wolfgang Mehringer from the MATLAB in Erlangen, Germany. My topic is an image-based method for measuring strabismus in virtual reality. Strabismus is manifested as a misalignment of the eyes. It affects our depth perception and causes amblyopia, which heavily reduces quality of life. To avoid that, we have to accurately measure the misalignment to compensate it. By now, strabismus is measured manually or with complex systems. Therefore, we wanted to create a virtual reality system easy to use and without expensive additional hardware like eye tracking. Hope to see you all in the poster exhibition.
Hello again. So these were the poster fast forward videos, and now I will show you all the demonstration pitches. We have 2 sessions, one today and one tomorrow for posters and demos. If you do not find one of these demos today in the expo hall, do not worry, you can look for them tomorrow. They will be there. So please play the videos of the fast forward. So these were the videos of our posters and demos, the fast forward videos. I would like to make a few announcements. So before we go to the expo hall. So the first thing is, you all can vote for the best demo. We've announced it on Wova poll for best demos. We have 2 sessions. I would like to remember you all. So you can check the first half today and the second half tomorrow, then vote. Yeah. On the expo hall, we have not only posters and demos, but also we have stands, booths for our sponsors, labs, and it's an amazing space for interaction. You can interact with all posters and demos once you enter in their booth area. It's a blue area, but we also can talk on the corridors, right? There are two ways to go to the expo hall. You can walk there. You can also use the go-to feature here in Virbela and teleport directly to the smart expo hall. And that's it. I appreciate you all here. I hope you all enjoy and see you in the expo hall in a few minutes. Thank you.
Thanks, Lucas. Now we finish this session. If anyone faces any problems or has any doubts, please talk to us, talk to a student volunteer. We are here to help you out. So please enjoy. The Expo Hall is a great place for interaction, for networking. So go there and enjoy. Thank you.
Sitzt immer noch alle? Ja, es sind jetzt wieder über den ganzen Raum hörbar.
Wahrscheinlich, ja. Lass uns rausgehen.
Gehen die Expo.
Uepa.
Hi, Veronica.
Which number? Sorry.
I'm here.
Actually, it's a moment. Hi, Indira. So can you follow me, please?
Yes. Oh. Got it.
Okay, very
Welcome to the iLearn Virtual Campus. Please sign up for a free iLearn membership on our website. Check out our seventh annual conference coming 2021, and let us know if you're interested in hosting events or leasing space on our campus by emailing campus@immersivelrn.org.